Welcome back to my algebra class. Let's go ahead and knock out the homework for 3-8. We're going to do 1 through 22 and then 39 through 42. On number 1, it says in exercise 1 through 6, determine the function when the function is positive, when it's negative, when it's increasing or decreasing, and then describe the end behavior of the function. Well, okay, so let's start with positive. We know that it's, remember, we're comparing everything to y, all right? So y is going to be positive when x is, less than, less than 0, when it's also greater than 0, right? But it's not going to be at 0. It's going to be negative. It's never going to be negative, right? There's never going to be a negative y because it stops at 0 and then goes back up. It's increasing when it's greater, right? When it's greater than 0. It's decreasing when it's less than 0, right? And then describe the end behavior. Well, y is going to, we're going to have, y is going to negative infinity, x is going to negative infinity, right? And as y is going to, as y is going to positive infinity, right? X is going to be going to negative infinity and positive infinity. So let's go ahead and review this again. The function is positive when x is less than 0, also when it's greater than 0, but not at 0. So you can't conclude that. It is never negative because y is never going to be negative. The function is decreasing when x is smaller than 0. It's increasing when x is greater than 0. As x approaches the negative infinity, right, y approaches the positive infinity. And as x approaches the positive infinity, right, then x approaches the positive infinity, the value of y approaches the, it says the value of y approaches the negative infinity. Let's see, make sure. As x approaches negative infinity, the y approaches the positive infinity, okay? And as x approaches the positive infinity, the y approaches the negative infinity. I disagree with that last statement. And let's look at this for a second. As y approaches the positive infinity, okay? As y approaches positive infinity, right? X is approaching the negative infinity. And as y approaches the positive infinity, x approaches the positive infinity. So this is a misprint. This should be y approaches the positive infinity, right? For both of these, you see positive infinity for y. So that's a misprint. The book put that wrong. So I'm going to scratch this out and put positive infinity. Okay. Number 2 is for you to do, and I'm going to move on. We're off to number 3 now. And I guess they're asking us the same questions, right? Determine the positive, negative, increasing, decreasing, and behavior. So the positive, let's see. Well, y is never going to be positive, right? As far as negative goes, while x is less than, well, we got to see what the slope is over here. And we see this as 1, right? And we see that we're going, the slope is 3, so that means we're going up 3 and over 1. So for it to go up 3 and over 1, it means that when I've only gone up 1, it's only gone up a third. So that means when x is less than 1/3, it's going to be negative. Also, when x is greater than 1/3, but not at 1/3. Remember, 1/3 would be excluded as one of the possible answers. As far as, let's see, we did, one will be positive and negative. The next question is increasing or decreasing. We know it's going to increase, right? when x is less than 1/3. It's going to decrease when x is greater than 1/3. And then as far as describing the end behavior, as x is going to the negative infinity, y is going to negative infinity, and as x is going to positive infinity, y is also going to negative infinity. So the function is negative, okay, when x is less than 1/3 or greater than 1/3, okay? It is never positive because it's never going to be up in the positive numbers of y. Describe the decrease when x is greater than 1/3. When x is greater than 1/3, it's decreasing. It's increasing when x is less than 1/3. And then as far as x approaches negative infinity, going this way, the value of y approaches negative infinity. And as x approaches positive infinity, the value of y approaches negative infinity again. This one is written correctly. So y is going toward negative infinity as x goes to negative infinity as x goes to negative infinity. And y is going to negative infinity as x goes to positive infinity. All right, you have number 4 to do. Did it say 1 through 6? You see, yep. So again, we've got to do number 5 now. Here, we see that x is going to be going up and down at -2, right? So when is it going to be positive y's? Well, positive y, we see that if this is -2, this is 3, 4, 5, -5. So when x is less than -5, y will be positive. Also, when x is greater than 1, it will be positive, right? When will it be negative? It will be negative when x is less than -5, but greater than -5 and less than 1. Now, as far as positive and when is it a positive or negative slope? It will be a positive slope, right? When x is greater than -2, it'll be a negative slope when x is less than -2. And as far as the infinities go, we know that as x gets to positive infinity, y will go to, as x goes to negative infinity, y will go to positive infinity. And as x goes to positive infinity, y will also go to positive infinity. So the function is positive when x is less than -5, right? Less than -5, it's positive y's. When it's greater than 1, right? Greater than 1, y will be positive. It's going to be negative when x is greater than -5, right? And then less than 1. We said it is decreasing when x is less than -2, right? Decreasing when x is less than -2. It's increasing when it's greater than -2. As x approaches the negative infinity, we said, the value of y approaches the positive infinity, right? As x is negative, y gets to positive numbers. As x approaches the positive infinity, right? Positive infinity for x, y will also be positive. So as y is positive, x is infinitely negative. And as y is positive, x is infinitely positive. All right, number 6 is for you to do. Number 7 through 10 says use the graph of f and h to describe the transformation from the graph of f to the graph of h. All right, so over here we see we have f of x minus 2. We've said before that when we have a f of x and we're talking subtracting or adding a number afterwards, this is going to be a horizontal, or excuse me, a vertical increase or decrease on our y-axis. So over here, we're going down to. So we're going to be going down to from the point of x minus 6, subtracting 2 from the value of f of x, okay, results in the graph of h. being a vertical translation, 2 units down from the graph, okay? 2 units down. Number 8 is for you to do. Number 9 has the function of 3 over 4x. We said whenever we had a fraction or a number next to x, but not outside where f is, this is going to go ahead and affect my x only, okay? So I'd be taking this 3/4, and then we'd go ahead and multiply it to -8, right? So on this one, we're taking 3/4 and of each x value, resulting in the graph of h being a horizontal stretch of the graph of f by a factor of 4/3. And remember, when we're doing factors, we take -8 and we divide it by 3/4, which means we're going to multiply it, right, by the inverse, which is 4/3. All right. Number 10 is for you to do. And number 11 through 20, it says, compare the graph of f of x equals the absolute value of x. Find the domain and the range, So now we have a -4 here, right? And we know that whenever we're adding or subtracting, we're going to have a vertical movement. So this is going to go ahead and give me a movement 4 down, right? So on this one, we're taking the -4, right? We're starting at -4 here, and then we don't know what x is, whether it's positive or negative, right? It's going to be coming up because these are always going to be positive numbers here. So we're going to notice that at 0, we're at -4, right? But since this is a slope of 1, remember there's 1 in front of this x, that's a rise of 1, and let me just put this here. That means this can be 1, right? 1x, or it could be -1x because this is absolute value. It could be either 1, right? So that's why over here we see an increase of up 1 and over 1, up 1 and over 1, up 1 and over 1, right? And over here we see a decrease of down 1 and over 1, down 1 and over 1, all the way till we get to 4. And that's why you see -2 is going to -2, right? And we see -1 is going to -3, all the way up until we get to 0, 4, right? And then we see the opposite, 1 and -3, and then 2 and -2, all right? So the function d is in the form of y equals fx plus k. We said when we have this form, we know we're going to be adding and subtracting, going up and down on the y-axis. So it says where k is -4, so the graph of d is a vertical translation 4 units down of the graph. So we're going 4 units down from the graph, right? So where we started, originally just an x, we're going 4 units down on the graph, right? So the domain is all real numbers, right? Remember, because the domain is my x, which means I'm going all the way. This arrow is going to keep going infinitely this way. This arrow is going to infinitely go this way. So all of the real numbers, right? But the range is going to be from -4 and up. So y has to be greater than or equal to -4. All right. Number 12 is for you to do. I'm headed off to number, let's erase this really quick. Okay, I'm going off and doing, if this was 11 through 20, I guess I've got number 13 next. If I did this one, I see x plus 1. And we remember this time, if it's included in there, I'm going to have a shift left and right. And we said that since this is the form that they want us to use is x minus h, this means we're going to be taking this positive one and turn it to a -1 as far as going side to side on my x-axis, right? And since this is going to make me go 1 over, right, to the negative side. So we see that we started here at 0, 0, 1, right? And then we're moving over from our origin 1 to -1, okay? And that's what we showed right here to -1. And then we still had x as a 1, And so the slope is still, just like I said last time, the slope is still going to be a 1 or a negative 1, right? So we know that, once again, this is going to be going up 1 over 1 on this side, right? Up 1 over 1, up 1 over 1, up 1 over 1, right? And then over here is going to be a negative 1, which would be down 1 over 1, down 1 over 1. That's what that absolute value does over here, all right? I'm sorry, wanted to erase this first. All right, so let's see. Number 14 was for you to do. I'm going to go to number 15. We had a negative in front of an x. We said whenever there was a negative in front of our x, then that was going to give us a reflection, right? And as you can see, we're taking a reflection here, which means we're going to be going downward. The function m is the form of y equals negative f of x, okay? Negative f of x. Notice the negative sign isn't in front of x, so it doesn't apply to x. It applies to the y. So all the y should become the opposite, all right? So it says, so the graph of m is a reflection in the x-axis of the graph of f, okay? So, so it says the domain is all the real numbers, and the range is y is going to be less than or equal to 0. Less than or equal to 0. Okay? Remember, y is what's going to change here, right? The opposites are going to, well, actually, y is going to stay negative. Yeah, the same. So we're having the opposite of y. Let's see. If we got x is 0, right? And remember, x is going to go ahead and stay the same, right? Up until it gets to the other side. So now we have 1 m of x, right? Because this is just applying to the y, right? The function of negative f of x. So this is going to give us where we would plug in negative 1, we would be going down 1 over 1, down 1 over 1 over here. We'd be going up 1 over 1 on this side. So, sorry. This is going to give me a line going up with a slant of 1 all the way to 0, and then a slope, I'm sorry, I should have said a slope of 1, and then a slope of negative 1 going down. Remember, a negative divided by negative is a positive, and a negative divided by a positive, or positive divided by negative, is a negative slope, okay? And I'm not quite sure, to be honest with you, why they have a negative 1 here. Or I'm sorry, why they have a 2 here. I think they should have had a negative 2 here, to be quite honest with you. Because when it's 2, it was negative 2. So I'm thinking that's another misprint. And I'm just going to change it here. All right. So that actually makes a little sense. Sorry, the book is new this year, and we're finding a lot of weird mistakes on it. All right. So we got the reflection across the x-axis, right? This flops everything downward, right, and creates the opposite. Where y was everything positive, now everything is negative. Okay. And for those that, if you couldn't see that, just realize at the beginning, this was what we've seen coming up this way. Our new one flips it down this way. And I'm going to say it again. The original slope was probably here, right? And then because we created this negative y, everything that was y becomes the negative value, the opposite. Okay? So everything that was, if they show this as the y-axis, then you'd be seeing that all of these would become the opposite, where this was 1 of 1, right? And you see over here 1 is negative 1, right? So where this was 1 and 1, right? Now it became 1 and negative 1. And so you can see that y is the thing that changed across all of this, okay? Because y was always positive, now it's always negative, all right? 16 is yours to do. And then you might notice that it has a negative inside of it, which means this is going to affect the x, not the f of x, which would be y. All right, let's go to number 17. Number 17 has a 1/3 in front of x, and we said if the number was outside of it, right, then we were going to go ahead and have this number multiplied to the to everything, right? So when we're doing this, what are we doing? We're taking 1/3, right, of whatever we had, because we're going to take 1/3 and multiply it to whatever that we were going with. So we've got 1/3 of x, right? So this shows me that I got a rise of 1 and a run of 3, okay? A rise of 1 and a run of 3. So what this does, and again, because this is the absolute value, right? And we already haven't moved it, we're going to start at the origin. And for all these that are positive numbers, we'll have a positive rise of 1 and over 3. But if this was a negative, right, then we would have the absolute value would come down, right? And that would be a negative slope because we'd be multiplying it to a negative number, right? And then it says the function p is in the form of y equals a of f x, right? Where 1/3, where a is 1/3. So the graph of p is a vertical shrink. And remember, vertical is this way, right? So it's a vertical shrink, 1/3, which means our line would have been bigger. It's getting smaller and smaller this way, right? Vertically, of the graph by a factor of 1/3. So everything is by a factor of 1/3. It's going down, right? So the domain is going to be all real numbers because this goes forever this way, x goes forever this way, and this way. Y is going to be from 0 up, right? From 0, greater than 0, equal to, or greater than 0. And if I didn't write that, or if I didn't go over that, I think I didn't, for number 15, please let me show. The domain is, once again, all real numbers, right? But the range over here is y will be less than or equal to 0. I'm sorry, I forgot to cover that before I left number 15. All right, let's see, we've got number 19 now. This time 5 is with x, which means the only thing that I'm going to multiply would be for a factor of 5 to x, okay? So in doing this, our x is actually going to be affected, right? So the function of the form of y equals f times a of x, where a is 5, so that the graph of a is a horizontal shrink. Now horizontal means, horizontal means this way, right? And they're saying a horizontal shrink by a factor of 1/5 of the graph, okay? So the domain is all real numbers, because this number is going to keep going this way, right? And these arrows, are going to go this way and this way infinitely. And then the range is going to be from 0 and greater, right? So this is going to be y has to be greater than or equal to 0. You might notice on the graph, if x was -2, right? X is -2, then -2 times 5 would be, -2, if this is a +2, then it would be 10, right? So +2 is going to be 10. And so -2 is going to be still going to be 10, okay? And that's because of the absolute value signs here. Let's see here. We're going to go, 20 was yours to do. To 21, it says in exercise 21 to 22, describe and correct the error in graphing the function. All right. Well, they got 1/4 of x, okay? And if you see, we got 1/4 of x, which means there should be a rise of 1 and a run of 4. This looks like it's a rise of 4 and a run of 1. So over here, because the equation is in the form of f of a of x, that means it's a factor, x is going to be affected by 1/4. So x will be 1/4, okay? That's a rise of 1, run of 4. Just like I said, it would not be 4/1. That would have put the number 4 there. 22 is for you to do. And it says, let's see, what was the error? Oh, okay. It says the graph should be a horizontal stretch by a factor of 4 on the graph instead of a horizontal shrink. Okay. And when we went up there, that was a horizontal shrink, right? And we wanted, it said it should be a horizontal stretch. Okay, so a stretch. And it should be a factor of 1/4. All right, 22 is for you. 39 through 42 say describe the transformation from the graph of F to the graph of G. Well, from the graph of F to the graph of G, first of all, we know that it went over, right, from here to here. If this is 4, then we can safely say this is 1, 2, 3, 4. That means it went over about 1.5. So that would have had to be like a negative 1.5 because it actually went to the right. And we know that we're going to be dealing with that x minus h, right? And it would have to be the opposite of that. But if you really, and if it would have stayed like this, you could have went with that. But here's the problem with that. If I was just to look at this as a translation, then I'd have to say, then what happened over here? Why did the slope become more steep? So I can't really go with a translation here. What am I noticing? First of all, I'm noticing that the slope went from x, right? This is a 1/1, right? So we went from x. And then it went to a, let's look at this. I'm going to judge it from here by the looks of it to here. And that's a rise of 1, 2, 3, 4/1. All right, so it went to 4/1. Okay, or 4x, right? So let's see. If we went from here to here, and we have to see, are we going to shrink it or are we going to stretch it? Now, what happened over here, though, from here to here? Now, we went down to 4, right? And this is 2, right? If this is negative 4 over here, this has to be negative 2. So what would have to happen for it to become 1/2? And that's what this looks like it is here, 1/2. Well, what would I do to 2 to go ahead and get it to 1/2? What would I have to multiply to it? Well, then that means I would be taking 1/2 and dividing it by 2 to find out. Okay? And if I did this, I'd have to do keep, change, flip, right? Which would give me 1/2 times, well, if I flip this, 1/2. And so now we see that it was 1/4 that happened, right? We multiplied everything to 1/4, which means this is not going to be a factor of 4. It's going to be a factor of 1/4, right? So what I'm thinking is we went 1/4, and then we multiplied it to the f of x on the outside, okay? And we're just going to check that out and see how I did there. No guarantees. Let's see. And I don't know how much of this is going to get used up, but we'll find out. Oh, it looks like over here. Let me erase this as well. We said it was a factor of 1/4 to the outside. Let's see. For the same y values and x values of g of x are 1/4 the x values of f of x. So the graph of g is a horizontal shrink. It did shrink, right, by 1/4 of the graph by a factor of 1/4. Okay, so the whole thing got affected by 1/4, not just the x, but the f of x. Okay, so the values of g of x are 1/4 the x values of f of x. All right, number 20 is for you to do. Let's look at number 41 here. For 41, I see that we started here at, looks like -2 and 1, and somehow it reflected over, didn't it? So I'm sensing a bit of reflection. So since it's reflecting across the x-axis, I would say this is a reflection of f of x over the x-axis, right? Because we're looking at it being perfectly, this was -2 and 1. Now it's -2 and -1, right? So, yeah, it looks like it's, since it's going to be off the x-axis, that means all the y's are going to change. I'm going to say then that it was probably a negative f of x. So, yeah, it's going to be a reflection over the x-axis. Let's see how I did on this one. From the graph of G is a reflection of the graph of F in the x-axis. Perfect. Okay. Let's see, 42 is for you to do. Oh, looked like that was the end. So the rest were for you to do. I guess I'll see you in class for grading. Good luck.